Alright, hello everybody. Here's comparing quadratic functions. I'm on 8.4. These are geared to problems 45 through 54. Let's take a look at some of these. Here's 39, or 39 to 54. Alright, so here's some problems. Graph the functions, compare the functions. Alright, actually I'm going to do this one without graphing the scissors, but it says compare the functions to f of x equals x squared. Alright, so here's my f of x equals x squared. So here's my parent function, and I want to compare this function h of x compared to my parent function. All right, so my parent function here, what's happening? What is h of x doing? So the parent function typically right here, so this is at my origin, it's not moving, it's my u shape, all right, and then what's happening to h of x? All right, so we have the x minus 2, which means I'm shifting my vertex 2 units to the right, and then my vertex is also going 4 units up. All right, so we have two transformations going on here. That's what I'm asking you to do here. Compare the transformations, write down some transformations that you have. So first we have a horizontal translation or shift, 2 units to the right. And the second one, we have a vertical translation, 4 units up. Alright, so that's what I'm comparing number 39 here. And there's a couple other ones you can compare as well. And I guess we could do one more. Let's do 42 for this one. So we have a couple things going on here, right? So we have the n of x equals the negative quantity of x plus 4 squared plus 2. Again, I'm comparing this to my parent graph, right? My parent graph is x squared here at the origin, and what's happening? So the plus 4 is going to move this 1, 2, 3, 4 units to the left, okay? Up 2, and there's my new vertex, and this time my negative sign here is making this graph go down. Okay, so we have, let's use a proper notation here. So 1, I'm just going to go left to right, so that negative sign means I have a reflection over the x-axis. Right, in comparison. 2, I have a horizontal translation, 4 units to the left. And then 3, I have a vertical translation, 2 units up. All right, and that's my comparison to the f of x equals x squared. All right, so there's 2 quick examples of the problems 39 through 42. All right, let's continue forward here, see what else we got. And here it says 49 is match the graph. And so you have f of x equals x minus 2 squared plus 1. And then you have let's look at number 4. It says 45 says g of x equals f of x plus 1. So something's happening here. So this is so g of x is not equal to f of x, right? Otherwise they would be the same exact graph. So what I'm doing is I'm taking my x value and I'm subtracting 1 to it. So if I rewrote f of x, so this is g of x equals, the f of x function is x minus 2 squared plus 1, but instead of writing x here, I'm going to replace that x with x minus 1. Right, so g of x is equal to f of x minus 1. So this x minus 1 goes in for x. Alright, so the x minus 1 goes in for the x here. So now if I simplify this, I have g of x equals x minus 1 minus 2, which is x minus 3 squared plus 1. So initially my f of x function was f of x equals x minus 2 squared plus 1, which means I was going 2 units to the right, 1, 2, and 1 unit up, and my vertex was there. And then my graph, right? And then my U shape going this way. But now when I simplify g of x, well now I'm at x minus 3, so I went 1 unit to the right. So here's 3 units. X minus 3 means I'm going 3 units right and 1 unit up. So what happened here? So what's going on in that piece there? So my vertex was 2, 1, now it's 3, 1. And that's what this means here, right? This is a horizontal shift, right? That f of x minus 1 is another way of saying you have a horizontal translation 1 unit to the right. So I took my graph, x minus 2 plus 1, 2, 1, there's my vertex, and I moved it over 1 unit to the right. Okay, so 45 is A. Alright, I'll give you a chance to try some of the other ones again. So you have sometimes where you have horizontal translations, sometimes you have vertical translations, sometimes you have reflections. Okay, so I leave it up to you to try 46, 47, 48, and ask questions when we have our session. Okay, and here's another example. It says graph G. Okay, and we'll take a look at number 49. So here's 49, f of x equals 2 times the quantity of x minus 1 squared plus x. And you can go about this a couple ways. Okay, you can graph of x, f of x equals this whole piece here, you can graph this function, and then you can apply this f of x plus 3. Now, what this f of x plus 3 is, similar to the last problem, is, well, it's not equal to, so g of x is not equal to f of x, it's equal to f of x plus 3. So this is telling me to take my function and give it a horizontal shift 3 units to the left. Okay, well, that's true. So if I'm going to go take my function and move it 3 units to the left, well, here's my, what's my hk? What's my vertex of this function? My vertex is 1, comma 1. So here's 1, 1. There's my vertex of f of x. And this is telling me to take my function and move it 3 units to the left. So 1, 2, 3. And then start my U shape. Okay, so let's just verify that that actually happened. So g of x is equal to f of x, which is 2 times the quantity of x minus 1 squared plus 1. So this would be me writing g of x is equal to f of x, right, which is not true. We're saying g of x is equal to f of x plus 3. So this x plus 3 is going to go in for x. And so I'm going to add the x plus 3 in there in order to make this true statement of g of x equals. So this is x plus 3 instead of x. Okay, so now if I simplify this, I have g of x equals 2 times the quantity of x plus 3 minus 1. Alright, so that's plus 2 squared plus 1, which again means my vertex is negative 2 comma 1. Alright, there's my vertex. I have a vertical stretch by a factor of 2, which is fine, but negative 2, 1, and this is indeed negative 2 comma 1. Alright, and then you could graph a couple points here, and you could see, okay, let me see what my next coordinates here are to graph this. So you could test g of, since this is negative 2, I'm going to test g of negative 1, which is going to equal g of negative 3, right? So 1 unit to the left, 1 unit to the right, and 1 unit to the left should give me the same y value. So if I take g of negative 1, if I plug negative 1 here, negative 1 plus 2 is 1, 1 squared is 1, 1 times 2 is 2, 2 plus 1 is 3, so when x is negative 1, we get 1, 2, 3. Alright, and the same thing is going to happen here because they are symmetric. Alright, and then let's do one more for fun. Alright, and then let's say I chose -2, I'm going to choose 0, and let's put 0 in here. So 0 plus 2, and again, g of 0 is going to equal the same as g of -4, right? Because I'm using 2 units to the right. 2 units to the right brings me to 0. 2 units to the left brings me to -4, so they should have the same y value. 0 is obviously easier to evaluate. So 0 plus 2 is 2, 2 squared is 4, 4 times 2 is 8, 8 plus 1 is 9, so when x is 0, y is 9. Alright, so I have my axis of symmetry here at the origin, right there, and because I am traveling 2 units to the right of the axis of symmetry, or 2 units to the right of the vertex, and I'm up 9 units, then here, and 2 units should bring me there as well, right? So now I'm the same distance from the axis of symmetry and the same height as well. And there's enough coordinates to graph my parabola. Again, it's a little freehand, but you get the idea.